All right, this is Calc AB Notes 2, page 3, second video, because we are halfway down the page, basically. We spent some time doing those, got them all right on the first shot, very impressed with that. And what we're going to do now is really, really common, actually. So a lot of the times when you're finding derivatives, especially in AP Calculus, because they want to try to like even the digital divide, and like some people have a CAS calculator. If you're in my class, you have a CAS calculator. Some people don't have a CAS calculator. You need to do something to try to even the playing field. And one of the things you can do is just use function notation instead of giving actual functions. I mean, you saw when I checked on the previous problem, when I checked all these, it took me like, I don't know, 40 seconds to do all of these because the calculator can just do it. Whereas this is more challenging to get the calculator to do by a long shot. So let's see if we can do them. So we want to find the first derivative of each of the following. Well, this is a first for us because this is a composition, but it's actually like 3 deep, right? So I look at it and I see, so I'll write them over on the side here. I see that y is equal to, let's say, f of u is equal to g of w, and then w is equal to x squared. So what does that mean for me? Well, what I can do, I want dy dx. So I'll just do dy du times du dw, because u is a function of w, times dw dx. That's what I'm going to do. I'm going to like chain my way through this. So we're looking for this, and there's that, and then this, and there's that. And then as long as you've set it up so that these along kind of the diagonals are working out, it's going to work out for you. It's a really neat thing that the chain rule works out that way. So what I'm going to do is I'm going to walk my way. So now you could do this. You could just like find those derivatives, sub in, whatever, and then back sub, right? Because you want your final answer to be a function of x, not of w, not of u, not of w, u, and x, just x. I'm going to find the derivative the way I usually do. So over here, I'm going to say dy dx is the derivative of f of something is just f prime of that thing. So what's that thing? It's g of x squared times the derivative of that thing. That thing is g of something. So the derivative of g of something is g prime of that thing times the derivative of that thing, which is just 2x. So I don't know that this is necessarily a better way to write it, but dy dx would be 2x f prime of g of x squared times g, I don't want that multiplication sign there, g prime of x squared. So that would be our derivative. And if you don't like the way that I did it, you can do it using the other method that I first wrote down. I just personally don't like that method all that much. I do think it's very clarifying though. And the harder the problem gets, the more likely I am to use that method. So knowing it is not optional. Like you need to be on top of what's happening. Let's write down in this function what we see happening. So if I gave you an x value, the first thing you would do is you would find the sine of x. So that's actually going to be the last thing that we take the derivative of. The next thing, after you find the sine of x, you'd find f of whatever you got. That's going to be the second to last thing we take the derivative of. Then, when you get that number, you take the cube root. Cube root is going to be the first function we take the derivative of. Let's write them down. So I'm going to say y is the cube root, but cube roots are terrible. So I'm going to say it's u to the 1/3. I'm going to say that u is equal to f of w, and w is equal to sine of x. All right, so I can find it's the same over here. It's the same chain rule type situation, so I'm not going to write it. But what we would do, dy dx is, so the derivative of 1/3 of something to the 1/3 is 1/3 that thing, but that thing is f of sine of x. So it's 1/3 that thing. Is that enough? 1, 2, I think so. So what I do here is I count like count the opening ones. See how many there are. There's 1, 2, 3. Count the closing ones. 1, 2, 3. So it's probably matched up to the negative 2/3. So derivative oh my God. The derivative of something to the 1/3 is 1/3 that thing to the negative 2/3 times the derivative of that thing. The derivative of that thing is f prime of something. times the derivative of that thing. The derivative sign of something is cosine of x. So notice there are three functions. We basically take three derivatives, right? You get 1/3 something to the negative 2/3, you get f prime of something, you get cosine of x. So three derivatives because there are three functions. A weird mistake that I see people make is they start like over chain ruling, right? Like we have our three initial functions, which look like this, then this, then this. Those are the only derivatives that you're going to take. So we ended up with, this is the result of the first one. And then this is the result of the second one. And then this is the result of the third one. Three functions being composed, three derivatives in your chain rule. You're not going to get more than that. All right, let's take a look at the next problem. Let's see how it goes. And all, so your inclination on the previous problems is like, how do they clean up? They don't. It's not going to get any better than that. I don't know. You can make it 1/3 cosine and then go with it, but what's the difference? All right, let's see if we can do this. We got to find it. So h of x has a weird definition. H of x is this thing. So h of x is this, and we want to find h of 2, h prime of 2, and we have this table of values. The table of values gives us f of x, f prime of x, g of x, g prime of x. Make sure you read those, the column headings, because sometimes you're given f, g, f prime, g prime. Sometimes it's f, f prime, g, g prime. There's not really like a consensus on how those tables are created. So you definitely need to make sure you're using the right values. So I usually on these write more than I find my students write, and I wish I could make my students write more, but who am I? So h of 2 is going to be the quantity f of g of 2 and then squared. So that's going to be the quantity f of, what is g of 2, right? So first thing I'm going to find is g of 2. And I'm going to find that because it's like the innermost thing. So g of 2 on the table is 5. And we're going to square. Now the next thing that I'm going to find is f of 5. So f of 5 in the table is -6. And then we'll square it. So 36. Okay, that's h of 2. Now h prime of x I have to find before I can find h prime of 2. So h prime of x, it's a chain rule thing, right? So I see something squared, so the derivative of that is 2 times that thing. So I actually don't need that parenthesis, and there's more than enough to go around. So 2 times that thing to the first times the derivative of that thing, which will be f prime of that thing, times the derivative of that thing, which will be g prime of x. Okay, so it's 2 times that thing to the first times the derivative of that thing, which is f prime of something, times the derivative of that thing, which is g prime of x. So it works. If you want, you can write it out. You could write y is equal to u squared, u is equal to f of w, w is equal to g of x. And you can go for it. If you need to do that, do it. It's not a problem. I crashed it. Hold on. I'm back. All right, let's see. So h prime of 2 is going to be 2 times f of g of 2 times f prime of g of 2 times g prime of 2. So write it out. There's nothing wrong with that. And then do it a step at a time, right? We need to find, I first need to find g of 2. I'm going to replace both of those with whatever I find. So g of 2 is 5. So it's going to be 2f of 5 times f prime of 5 times g prime of 2, you can actually just read off as -3. Okay, and I acknowledge this is more writing than you want to do, but do it. So now we got to find f of 5. F of 5 is -6, so this is going to be 2 -6. F prime of 5 is something we can find now. So we're going to find this. F prime of 5 is -4. The worst part about these is that it's very hard to check them. Like I'm not gonna be able to just bust out the calculator and get it. So what is this? Negative 12 times 12, negative 144. So I'm getting negative 144. I think that that is the final value of h prime of 2. I mean, we could check, but like, I don't know what I'm checking really. Like g of 2, did I get it right? G of 2 should be 5. I got that right. F of 5 is negative 6. F prime of 5 is negative 4. G prime of 2 is negative 3. And then if I multiply it, I got it right. I mean, hopefully I did. So let's see. The tangent line is going to be y minus what we got. So 36 equals the slope, negative 144, then x minus 2. That's our tangent line. Therefore, h of 2.1 is approximately, why do you keep crashing? Okay, is approximately 36 minus 144, and then I'm plugging in 2.1 minus 2. So what is this? 36 minus, I'm going to say 14.4. Okay, and then 36 minus 14, well, 36 minus 15. What am I doing? 21.6, I think. 21.6. If I add 0.4 to that, I get 22, and if I add 14 to that, I get 36. 21.6, I think, is my approximation. So the approximation can't focus on that enough. Got to be approximately, because it's definitely not equal to that. All right, let's do this last thing. So we want to approximate h prime of 3.4. Really, really important to remember that when you're approximating h prime of anything, you're using a secant line to do it. So what we're going to do is we'll just use a secant line between 2 and 5, because those are the only values that we have in the table anyway. But we're going to use a secant line. So I actually need to know what h of 2 is, but h of 2 we found, thank goodness. 36. I need to know h of 5 also, which is going to be the quantity f of g of 5 squared. So that's f of, well, the quantity f of, what is g of 5? G of 5 is 2. So f of 2 squared. F of 2 is 4 squared is 16. Okay, so now my work is going to say h prime of 3.4 is approximately, and I like to just show it. So h of 5 minus h of, so there's no question when someone goes back to read your work, and they're like, yeah, but I don't really see what you did. Like, oh, they're going to see it because you're going to write it out. So 36 minus 16, this is working out really nicely, which makes me think it's probably wrong. 20 divided by 2, 10. So I'm going to say h prime of 3 is the worst. 3.4 is okay, so now I messed myself up by doing that. I'm going to say, because you have to say approximately at the end, so I'm going to say that. I think that's my approximation. So should I check it? Probably. Am I going to? I don't know. G of 5 is definitely 2. F of 2 is definitely 4. 4 squared is definitely 16. I don't know. I feel pretty good about it. I tried my best. That's all anybody asks. So this is different ways of looking at the chain rule, using the chain rule in problems. When a table is involved, you got to be really careful and just write it out. Show your steps. Always show a derivative without something subbed in before you sub it in. So like under no circumstances would I have tried to jump to this. There's no way. Do not try to jump to this. First, show this, then you can show this. Always. Because you want people to know what you're doing. But anyway, I'm going to wrap this up here, come back in another video, and keep going. So I will see you there.